go ahead and so what I'm going to do is I'm going to be very basic because I would like everyone to I felt like oops, oh, it's forcing me to do, oh my goodness. All right. Security and privacy. I should have tested this. I should have tested to make sure I could share my screen properly. I apologize. This is okay. This is some amateur stuff right here. I'm getting an error on my computer saying I'm not allowed to share my screen. So I have to, does anyone have, there we go. All right. Yeah, I have to click. It's my NASA computer. So I normally use Zoom in the window. And I have to quit and reopen. I apologize. I'll be right back. Already.
All right, so while we wait for Barbara, I'm going to paste a link to the GitHub repository. We'll be keeping all of the tutorials. And the tutorials, initially, we're going to try running them as much as possible through Google Colab and Jupyter Notebook. So Jupyter Notebook is very similar to the IDL and MATLAB interface. It's an interactive development environment. And so you'll be able to run the code through the Jupyter Notebook. And since we're using Colab, you don't need to have any Python installed. So if you click on the link and then click on in the table in the bottom of the GitHub there, the opening Colab, you'll be able to access the first Jupyter Notebook for today.
Thanks, Kyle. Now I need to be allowed to share my screen now. Now you have me disabled. Oh, great. Now it works.
Yeah, I just made you co-host again.
Wonderful. Awesome. I apologize for that. I normally use Zoom in the browser, and this time I tried using my Zoom instance, and it's picky. So hopefully you can see me okay. And then
yep.
You can see me going to the Magnetosphere online seminar series page. Is that correct?
Yeah, now we can see the page as well.
Okay, great. And so, and I know that some people, if they join, they may not be able to find the links quickly. And so if somebody says, where is this? I hope that you guys will all help me keep people who are joining updated on how to find stuff. But if you go to the Magnetosphere online seminar pages, there's the Magnetosphere online seminar series tutorials. And then the site for the tutorial material is a GitHub repository. And that's where you're going to find this link here, Open in Colab. That's the Google Colab code notebook that we're going to use for the tutorial. First of all, though, I'd like to go over some intro materials. So this is the first tutorial in Python coding for Heliophysics. And I'm teaching it because it's the only one I'm capable of teaching. I am not an advanced Python programmer by any standards. And one of the things that frustrated me when I was learning Python was that people didn't kind of back up and talk about the principles behind Python more, so that I could really understand what was different about Python, what was the same, and so that I could leverage previous knowledge. And so this series is intended for beginners who are not really familiar with Python or are just getting started. However, I see a lot of people on in the participant list who are experienced. Please stick around, especially those of you who I recruited to help answer questions. For the audience, if you're in Zoom, please feel free to post questions, add your thoughts on the course materials. The coding environment changes rapidly, and so I might have some information that's a little outdated or even incorrect. So if you do have something that you'd like to embellish, feel free. Kyle and Remya are welcome to also participate in this. Help, if there's a good question, bring it to me quickly. And if people would like to, and also if you guys have comments or something, feel free to. And then again, if you're really inspired by this or want to have something that you'd like to help learn, our community learn, you can volunteer for an upcoming tutorial. But first of all, let's try this. Why would you want to learn Python? For most of us, Python is not the first programming language that you've learned. In fact, I was going through trying to remember all the languages, and yeah, I'm about 10. I've learned about 10 programming languages. And so when Python was coming around, I was thinking, oh no, not another one. I've had to function in Fortran, C, MATLAB, and IDL all these years, and to be able to do the different things I do. And now I'm supposed to learn a new language. And so, and there are barriers every time you try to learn a new language. First and foremost, it's a huge commitment. A lot of us don't have a lot of time. A lot of us have a lot of things to think about. And so so in terms of time and mental energy, it's a drain on sometimes your resources that you're already in need of conserving. Another thing, if you have learned a lot of language, is that the way that you do things in the language can get garbled with previous languages. You can be like, okay, now this one, how do I do this? Is it similar to this? Is it similar this way? How do I do a loop? There's so many for loops that you'll do, and trying to figure out, for that particular language, how to do that versus this. It can be very frustrating once it gets piled on. Another thing that's a huge impediment again is that if you haven't been programming in Python, most of the stuff that you've done is in a different language. And so you're going to have to figure out how to either convert what you have into Python, or find a way to merge them together so that the two languages that you're using can work compatibly. But there are some good strategies if you are committed to learning Python. With any language, immersion works best. If you're trying to learn a new spoken language, you know that if you sit in class and you take the class and then you don't think about it until the next time in your class, you don't pick it up quickly. The best way to learn a language is go to a place where they only speak that language, and you just have to at first it's hard, but you learn very quickly when that's the only way you're allowing yourself to function. Another good thing that help you learn with Python is there are unparalleled resources that help you learn. And some people, we have different learning styles. I think by now, like most people, once you're at the level that you're at, you have a familiarity with the way you tend to learn well. Some people prefer an instructor-led course where an instructor brings you through the principles, and this person who's a professional tells you things and gives you homework, and you have a timeline set by externally so that you're able to keep on pace. Some people prefer self-paced learning. The course is either too slow or too quick. It requires commitment though, because you're your own instructor in that case. There's also some people like to watch YouTube videos, like this will be a video. And some people like to follow on written instructions, and that Colab notebook that we have is a written tutorial as well. Sometimes you like to learn the theory, sometimes you just like to get started. There's no way to learn. And learning what you think works well will help a lot, and sometimes a hybrid works well. Sometimes you want to take a lecture for an advanced principle, whereas if you'd like to learn something over a wide range of concepts, you can just start poking through tutorials online. Another good reason to learn Python is you do not have to be an expert to make a lot of progress. I've heard multiple people say that even though they program primarily in Python now, if the internet is down, they're useless, meaning that there are so many resources that have references for code, have instructions, you can look up things, you can find libraries and tutorials and galleries and examples that you can use to put into your code. So you don't have to really write a whole lot from scratch. You can find someone who has who's already done it, and then use it yourself. And that's another wonderful thing about Python is it is so fundamentally open code, open sharing. People who write in Python typically try to share and try to make it available to others. So if one person's learned it, you know it. You just got to figure out who it is and where you can find that information. If it is your first language, I have to say that it is a great first language. The gap between conceptualizing kind of what you want your computer to do and what you tell and how do you code it, the syntax, is smaller than for a lot of other languages. It is a language that is very optimized for scientific analysis and data science. And so it is a good language to start with. We did a survey on helionauts.org. If there are any Helionauts people here, please give the join code or to generate a join code, or you can contact me or one of the Helionauts team. This is a message board, a discourse group that for the heliophysics community. The only requirement is you have to be affiliated with a heliophysics institution. But I posted a survey and I said, what are good reasons to overcome the burden of learning a new language? And first and foremost, it's the support. Python has a larger support community than any other language. It's just extraordinary. You can find things quickly. And there's lots of examples. People share their code, they post it. And because of the sharing, again, chances are that someone has already done what you're trying to do. And if they know it, they're sharing it, and you now know it. So there's extensive code available for reuse. And if you share code, it's also possible that someone will make an improvement that you'll find useful, or even find an error, so that your code will be more robust because it will be evaluated. Another reason Python's versatile. It excels in science, but it also excels in general purpose programming. And so let's say that you would like to take what you've done now and make a web interface for it, or do things that preparation for publication. There's a lot of scientific ideas. Also, there's a lot of when your idea goes from research to operations. Let's say you're trying to do something that's a forecasting tool. There is a lot of preparation, and Python is able to help migrate that into an operational environment as well. It's efficient. It's very efficient. People report that the time spent coding to get results in Python is shorter than in other language. It's quicker, partly because of the learning environment, partly because of the way that it's optimized. And another great reason to learn Python is it's so useful for other things. I find myself, I keep Python running all the time because I just like to do basic household math with it. If I'm trying to figure out what 14% of something is, I have that. I can generate an array really quick based on dates, and I can make a schedule. I can figure out different things. It's useful for lots of things. And so if you're staying in heliophysics, Python is applicable to many other things. I was building something called a web scraper, which is just a thing that you can take a web page and extract that information that you need from it and build a data structure based on that web page. And so as it updates, you can grab the new data out of that web page without having to manually do that. But also, if you're considering going somewhere else, you have to, Python is a great backup skill. And so Indeed.com is a common resume service. It's pretty comprehensive. And the most popular data science software, and to be a data scientist, it's a broad field. It's anyone who's taking information and manipulating it in a way, or taking data and manipulating it in a way so that you can derive information and knowledge from it. And so there's data sciences all over. And the most recent survey that I could find from 2019 is the number of data science jobs with a data science software prerequisite. Python is in the lead, past Java, past SQL, past lots of things. So yeah, there's a lot of other great reasons for learning Python. Again, you can do things other than just numerical data. Natural language processing, there's knowledge management that can be done that's important for our field, but it's language based, it's not data based. There's a pretty seamless integration of data type definitions and units. And so if you're working in meters, kilometers, yards, or whatever your units are, it's pretty seamless that you can define your data types so that you don't have to do that conversion. It keeps track of the units for you, which is great. Most of this stuff is open source. There's no purchasing obstacles, and there's less difficulty collaborating, especially with international colleagues. If you have the money to purchase some excellent software that's available, that's great. But it means that if someone else does not have the funding to purchase it, it becomes an impediment to collaboration and sharing. It's portable. We're going to do the tutorial in a browser. You're going to run code in a browser, which is pretty cool. It's pretty straightforward. And then I think the best thing about Python is that all of the libraries and the packages that are available that make you able to do just about anything. And even if you're not working exclusively in Python, there are extensions that are, I think John Dorelli that used the term relatively painless to integrate, to use your Python to build extensions in different types of computing code. There's support for high performance and cloud computing and handling large data volumes in Python. And even if you don't intend to use Python regularly, you probably have collaborators who will be using Python. And so it's good to at least be mindful of what they, how you'd be able to collaborate with them. Right. And then, people always ask like, well, okay, I'll learn Python, but will this be the last language I have to learn? And I'm just probably not. But hopefully Python does seem to have staying power. So I do think it's a good investment. All right. So Kyle, how's things going? Am I still online?
Yeah, you're still online and we're still progressing.
Yeah. That's always the thing that happens in online things is you can drop out and be talking and nobody will know that the speaker won't know. Anyway, so if I'm still online, the next thing, are there any questions that have appeared in the chat yet?
We have two comments and a question. One from Kataro, R is better. Damas asks, is Julia better than Python? And if I can step in quick, Barbara, I would say yes. A lot of programming does come down to personal preference and what you like. Barbara has made excellent points on Python. And I think one of the big things for Python that she hit on here is that the space physics, heliophysics communities, Python is the language that we're moving to, I think. We have a lot of support within the community for Python. And so some other languages will have their benefits, but in terms of what you might need access to because you're in space physics, magnetospheric physics, solar physics, a lot of that is already in Python. And that's one of the huge benefits that we have with Python right now for our community.
Yeah, I gotta say, I mean, I'm glad that Julia and R were mentioned. Yeah, you're not going to beat R when it comes to just ease of machine learning and model training. It is phenomenally easy. And some of the points I made about Python are not exclusive to Python. There's a tremendous support community for R. There's also a growing support community for Julia. However, again, like Kyle says, a lot of the packages that are being developed specific for instrumentation and access to the data and the models in our community, they're converging towards Python. So, but there's nothing stopping R from, or someone developing that in Julia and R, and I know some people are working on that. So if you go to the link, and you don't have to, if you choose to, you can follow along in the presentation in what we call a Jupyter Notebook. Jupyter is spelled, it's a portmanteau. It's Julia, Python, R, Jupyter. And so what I'm doing is I'm using a notebook for with a Python kernel that will allow us to run Python inside, but we could also be doing this tutorial in Julia or R. And and also these notebooks, you can put in extensions, IDL, MATLAB. There's a lot of ones that can be done through these notebooks. However, the one that we're using is the MyPython. The extension is IPYNB, which is the Python notebook. And then and so if you'll just follow through with me. So to get started, Python's pretty easy to run. And there's a couple ways you can do it. you can just write a file that you can make a file called just an ASCII file, a .py file, and then you can have it, and the standard in programming is hello world. And if you just put these 2 lines in an ASCII file, and if you have Python installed on your computer, if you don't worry about what Anaconda prompt is, we'll learn that a little bit later. But if you just then at your prompt, if you just type Python and then the name of the file, it'll give you the output. It'll print out hello world. And so if I do that, there you go, you get hello world. And so, yeah, that's standard for a lot of things, but but the nice thing about these notebooks is that you do not have to have Python installed to be able to do this. This is a Jupyter Notebook. Again, JU for Julia. Is this, let me see, maybe I need to make is this better with the bigger font?
Yeah, that's easier to read that way.
All right. Yeah, so Jupyter is Julia Python, and then R. It's how that is, it's where the name comes from. And you can edit it in a web browser on this Google Colab. You can interact with it and practice commands. You do not note that this is a sharing version, but you cannot save. Mine says all changes saved. Yours, if you play with it, you'll probably see that you cannot save here. What you'll have to do is you'll have to go to File, and if you want to save your changes, and either save, you could save right now if you want, save a copy in Google Drive, and then you could be editing your own copy, or whenever you're done, you can just go ahead and download it locally to your computer to save what you've done. But this is a view only. Well, it's not. You can manipulate it, but you can't save the changes. So yes. So and then so in this environment, there are 2 types of cells. The nice thing about a Python notebook is it runs the code, but it also has the explanation. It's called markup, and you are able to give a lot of information about you could preface things, you embed plots, you can embed videos in this notebook, in addition to having the code that you're running. And that's great because it really helps, not just for you can test and debug things very easily, but also it's great to share, because you're not just sharing what you did, you're sharing the explanation. And so somebody could very quickly reproduce what you did and follow it step by step. So yeah, so there are 2 types of code cells in this notebook. There's code and text. These text cells are, they use markup type formatting. And so if you just double click in the window for the markup, if you double click in there, you should see what it looks like here's the markup, and here's how it's rendered. And so you can fix it. Let's say I had a typo or something like that. I can go ahead and change that. And then let's see this. I can say there, I can say, but it helps. And then I can just go ahead, and the way that you complete whenever you've done an edit is you hit Shift, then Return. That should work on all of your computers. So what I want you guys to do if you're following on the tutorial is just first and foremost, double click in this window and change the name. If you double click it, you can see that it's right now it just says my name is Title or Jordan. What you'll want to do is you'll want to change your name to your real name, or whatever your chosen avatar name is, and then hit Shift Return, and there. Is everybody okay with that? Did everybody who tried that, or were they able to do it?
Yep.
Okay, and then again, anyone who has questions, there's lots of experts online. You can ask people. You can ask people how if you get stuck, please feel free. Now that's not code yet. That's just the markup. But the wonderful thing about the markup is this is like having a research paper with the plots and the data embedded in it and interactive. So let's move on. The Jupyter Notebooks. These are Jupyter Notebooks. These are interactive forms of code. And again, there's other types of code, though I think the most common use is Python. And there are advantages to working with Jupyter Notebooks rather than just straightforward .py Python code files. And first of all, again, they are a useful hybrid of interactive terminal and self-contained script. It is a document format that allows executable code. It has formatted text, but also graphics and interactive features. And it's combined into a single document that you can share. Though this notebook, again, I keep on saying this, I apologize, but yeah, the notebook has been made compatible with a large number of programming languages, which is really nice too. So if you're sharing through notebooks, you can also work within MATLAB, IDL, or anything, or a lot of things if they're integrated with the Python, with the Jupyter form, with Jupyter. But the best thing I think is that it's so useful as a development environment. It really allows people to, you can share, you get rich information, both the computational and data derivative narratives, and it mixes it all together. And it's this hybrid of both the code and the output of that code and the annotation. There we go. See, I found it. There we go. Annotation. There we go. I fixed that. Annotation that make it ideal for collaboration and sharing. So again, these have all been text cells. If you would like to add another text cell, let's say for your own notes that you're going to save later, if you want, you go up here and you click plus text, and another cell will appear near here. And you can say, remember to check on resource. You can make notes to yourself. And then when you're finishing, you hit Shift Enter. And then you can, then you have the note for yourself. And then if you want, there's different formatting options here. I'm just going to delete that so that it's not confusing to people. But you can always see you always have an option of deleting, and you can move things, move cells within this. All right, so, and then this little window, you can collapse things. Maybe I'll collapse so that you can see this table of contents. So we're gonna go now next to just starting with basic Python code. In the code files example, you saw that what it looks like in Python to say hello world in a Python script. However, you can run this now executable inside the notebook, and you can see that there's a little arrow here. You can either hit this to run the cell, and then what it'll do is it will print hello world, or if you want, you can, again, just like you do with the text, you hit Shift Return, and it'll execute it for you. And so you can, and if you watch, I'll remove the comma and hit Shift Return, it'll run again. And then you can move on to the next one, and you can say hello to you too. And that'll tell you you can click and edit the cells. And again, if you look, these are code cells and these are text cells. And so again, Shift Return to execute, but the way that the code cells are expecting it to be Python commands and not text not text commands. Now this is a text print, the way you print text in Python. You print out, you call the print statement, but as opposed to in Markdown, in this text cell, I just have to write hello world. This is the print statement. And you'll see something interesting happening here as you run these. You'll see the 3. There's a 3 next to the first print statement, and there's a 4 next to the second print statement. Now I'm going to go ahead and just run this again. And now you'll see that the number is 5, then 4. And so what's happening is that it gives you the order in which things were executed. Now I think this is one of the things you got to be really careful when working in a notebook environment, is that you do not have to execute things out of order. Of course, you can go into the command. If you go up here, you can just go ahead and run everything all at once, which is a nice thing to do. Finish it, execute them all, and then you make sure that they run in order. But when you're debugging, what you'll often do is you'll go back and you'll try to fix something, and then you might forget to run it all through again. And so what's happened now is we've run hello, hello. We have not run index equal to 0 yet. What I'm now doing is I'm just defining a variable. It's called index, and I'm setting it equal to 0. And so then if I run that, now I have an index. A variable named index has been created, and it's the 6th command that I've run, index equal to 0. And so you'll start to see these numbers be different. It'll keep track of you when these things ran. And what you might want to do is you might want to just restart it completely, reset it. And then you'll see that this resets to something. But it resets to nothing running. But if I do this, let's say that I add a code thing and I say print index, it's going to say, what do you mean? Because I have reset everything. But if I run index equal to 0 and I have print index, it's gonna give me the index. So that's just a little bit. I find that sometimes I run into pitfalls because I forget that I ran things out of order. And for example, let's say this index equals index plus 2. This is not a for loop. This is just a command. This is just a command segment. And so if I hit that, again, and you guys can do this, click in the window and hit shift return or hit the left arrow. And what you'll do is you'll find if every time I run this, it is increasing index by 2 and squaring it. And so it's going to give you a variety. It's going to give you whatever index is. It's changing it. And so unlike if you're just running a program in isolation, it'll execute in order. This can go out of order. And so
Barbara, sorry, I accidentally muted you because someone was in the waiting room and they got let in. Can you unmute yourself?
Oh, okay.
Sorry about that.
How long was I muted?
Only a few seconds. I tried to
Okay.
let someone in from the waiting room, but someone else did, and I hit the button by accident.
Oh, okay. Well, that's the way it goes. All right. Yeah. So anyways, and so if you guys want, you can add a code segment, and you could go index 2 equals 1, for example, and you can play with that a little bit. Get a sense of how you can interact with the notebook and display your results or print out your results. And again, you want to restart the runtime if you want to make sure that these things are editing and are going in order. Now, yeah, and then you can start debugging on the fly. Now, if you really want to get started in things, though, there are a variety of options to edit the Python code. There are, again, the Python notebooks are everyone's favorite way to collaborate because, again, the annotation, the display, everything is all integrated together. It's great. But they can mostly, for the most part, be edited as text files. But most people prefer to have an editor like this one that we're using that allow you to execute the code and the markup properties, not as a simple text file, but as a rendered environment. And if you've ever looked at like what Microsoft Word raw code looks like, it doesn't look anything like what you normally look at. What you're doing is you're doing a display environment where it's showing you what the rendering is. I think WYSIWYG is one of the terms that people will use. And so nobody edits Microsoft Word in raw source code. Well, very few people do. Normally they edit it in the software, Microsoft Word. They edited a Word document in the software to so that they're able to format it and have it do exactly what they want it to do. For this reason, a lot of us will use a what they call integrated development environment, an IDE. IDEs are like this, can help you write, test, debug, upload, and share code. if you have Google Colab, if your institution has a pro version, it's a great way to upload and share code. If you have the free version, then you have to work through it's a little bit harder to share, but it's still pretty good. And most of these IDEs have a free version. I like to use, I just have a local instance of Jupyter Lab that I run on my computer. That's one example of an environment that people have, and so that that people have. And I do that through the Anaconda distribution. And so these are, and that's one of the hard things about Python is there's so many options. There's so many options, and so and it might be tough to decide what is best for you. What I did is I just asked people what they use, and at the time the pros told me they use Pycharm, which is a great management environment for developing code and developing integrated code. And most people use Anaconda as their manager for managing packages in the distribution. So what I've just done here is there's many IDEs available. Here's some good options. That's a recent article on things that are there. Basically, if you're really advanced, you probably want to start with Pycharm. If you're not that advanced, just go. You can just start with this on. You can work with Colab, or maybe install a local Jupyter Lab environment in your on your computer. All right. So, and again, I apologize for not going through this too in depth, but everybody's different. And so we'd rather just do this, have people work this out and ask us some questions and be ready for the next tutorial once they've decided how they want to proceed in their development. I think a lot of you probably already have something. Feel free to post in the chat. If you're a Pycharm user, say what you like about Pycharm. If you just say, I only edit in Jupyter Lab, it's fine for me. If you're a cloud user, AWS Cloud, Amazon Cloud has, and Google Cloud have some great development things. And so it'd be nice to hear from people to give who are advanced to say what they use and why. What made you settle on these things? All right. So if you're developing, again, one of the most wonderful things about the Python universe is the fact that it's ideal. I mean, the community is really supporting code sharing and collaborating. And so if you're accessing this in Google Colab, again, the edits to the original file cannot be saved. But once you've saved your file, you can share it with others. And there's great advantages to sharing code. Saves you a lot of time. When one person figures out something, others don't have to. You can just cut and paste. You can save, you can start, let's say that you like what someone has done. You can take their notebook and edit it for your own use. If you have, if somebody's gone through a lot of work to acquire and analyze and display some data, and let's just say you just want to do the same thing for a different date range, pretty easy. You just go and change the date range, and you can reproduce everything they've done right there in the code that has been shared. Another thing that's good is it's very straightforward to validate. This is an era where, and I'm happy for it, that in science, it's very difficult to publish something that can't be validated or reproduced. There's a lot, they say a lie makes it all the way around the world before truth gets its boots on, meaning that, something that is incorrect, if you're trying to fix it, if you're trying to correct an error that has been out in the community, especially an error in knowledge, it's much harder to do than not to have the error really get out there in the first place. It's hard to chase it down. Our brains tend to learn, and then it's very hard to unlearn something. And so it's good to have things that are validatable from the outset, so that we don't have to unlearn something. We just learn, we get information correct in the first step from the start. And and all of us make errors. And if you don't make errors, then don't tell me, because it'll just make me feel bad. But I make so many errors, and I'm just glad that there's an environment that allows us to find those errors before I present it at a meeting or share it with a peer. So the work is straightforward to validate. It can embed all the steps from initial acquisition to preparation of the data and the production of the statistics and the graphics. And they can all be shared together in an easily reproducible form. And again, your own code can benefit because people can help optimize it and or find errors in it. And so you can quickly improve things. The most common way people share code is through GitHub. GitHub is it's got an extraordinary number of users, or at least user accounts, and GitHub is the environment through which people, there's the version control system is called Git, and that is something whenever you update code, it tracks the changes and it tracks all and it gives it it helps to version management. So if code is changed, you can go back and track what has been modified. Also, if someone is using your code, it's a great environment because it does help you track what has changed and update your code very easily. And it's great for collaboration because people will post their code on GitHub. They will manage their code through GitHub, and through version control, you can track the changes. You can you can do an audit trail, and you can keep track on. You can develop really pretty seamlessly together. If those of you have used online editing tools, whenever you're trying to edit a document and two of you make a change to a document and you try to save the document, and if you don't have a good seamless integration, you can overwrite someone's changes. But GitHub has an audit trail that allows you to check out the code and edit it and then merge it with other people's edits. So it's a great collaboration environment. And so hopefully one of the future courses we're going to teach here is all about Git and version control. How do you access code on Git? How do you share it? How do you modify it? But if you'd like to get started, there's an excellent course developed by the team at the Advanced Software Technology Group at Goddard. I really want to thank Jules Kowachu for the effort that he's made to develop these courses. And this is a good course that's online and available for anyone to take. And it's in the NASA Heliophysics community. This is what it's developed for. Please don't share it everywhere, because there's only so many people they can support. But if you're a heliophysicist, please feel free to take the course if you'd like to understand more about code sharing in the Git tutorial. All right, so we're getting towards the end, and this is what I'd like to prepare you for in the next courses. First of all, Python packages. One of the things that makes Python and similar languages most valuable is the extensive array of specifically developed packages for users. And in our field, in heliophysics, there's a wide variety of excellent packages that are available. Now, NumPy is a standard package in Python, and it's certainly one of the most popular because NumPy has core features that are central to numerical analysis, algebra, array manipulation, and different types of optimizations that are part of the way we do research with our data. And so that will be part of our next tutorial. But if you'd like to get started now, this is an excellent place to start, is the NumPy site. And that's and you'll be able to not just be able to manipulate the data, you'll also see lots of great ways to display and learn from the data. There's a lot of data exploration tools that are really excellent in NumPy, and then it's also kind of its descendant package, Pandas, which we'll also cover. So if you're going to do your install an IDE or choose one, they often come with standard packages, but eventually you're going to come up against a package that's not installed, which is why you'll want to either join a site like a cloud site that already has the packages installed, or most of us just go ahead and get a distribution manager on their own computer. Anaconda is the most common. Anaconda is the way that you can identify once you've seen a package or something, once you see something you want to do, and you say, okay, I can only do that with SpacePy or PlasmaPy, or that's where the package, that's where that software is. You can just go ahead. It's very easy to install the new packages, and then you can update the packages. And so we will not do this time because there's different environments that people might be working in. But there are excellent resources to understand how to get that set up on your own computer if you want to do local development and also make these packages available to you. But this is the neat thing. Okay, so there's homework. Yes, so for the next tutorial, if you guys haven't already done this, and I suspect a lot of you have, HelioPython, the Python and Heliophysics community is the premier group. It's a community-based group that coordinates the development and also the learning resources for Python packages in Heliophysics. And so your homework is to first go to those list of packages on the HelioPython page and see what they involve. If you have a data set or a model that you commonly use, go and figure out which packages allow you to access those data sets. There will be multiple ones. And so hopefully we will next time, if we have people run into trouble, I will there's a feedback form. If you run into trouble, give me your email address. We will find the package that does what you need it to do if you're not able to find it quickly. So go to review the list of packages. The second part of your homework is to pick a package that has a really good examples gallery or examples page. Plasma Pi is really great. What you can do is then you can if you go into Plasma Pi and say I want to do I want to generate a one-dimensional maximally distribution. And so this gives you, this is a notebook with the code embedded in it. And if you can launch it on this is a binder hub. This is a binder is a way that it runs executable notebooks just like Colab. And so what there's a link here. And so you can play with the you can play with this code here, and you can go into the examples page, and let's say how do I do this? How do I display this thing? How do I generate this type of function or something? How do you generate or display a non-uniform grid? Things like that. There's different simulations. Anyways, a lot of these galleries, a lot of these HelioPython projects have examples pages or galleries. So take a look. Take a look at something that looks hard, and then go in and try to understand or even run the code that allows you to do it. And the fact that they have them as interactive code means you don't even have to know how to do it because they have it there. Third, we'd like you to fill out the survey. Again, this has been a very, very, very basic intro. And I know that a lot of you experts have been doing email the whole time rather than having the simple stuff. But let us know what you'd like to see in the future tutorials. We have a lot of options that you can check, or you can put something else. And finally, like you said, you may want to install Anaconda or some sort of distribution manager so that you can work locally on your code. You can install packages and things. And you even might want to go ahead and start working with GitHub Desktop. So that you can start to share that code and access other people's code directly through GitHub. So we have there's a couple of free, just to close out, there's a couple of free books and texts that are excellent resources. They are free online texts, but if you want to support the developers, there are ways you can do that. And these developers really, they put a lot of effort into making these excellent resources. I posted my two favorites in terms of things to read, just to keep up on the pulse of data science. Towards Data Science and KD Nuggets are my favorites. You are free to, if you want to fill in the feedback form what your favorites are, we can add them to the list. I mentioned the Python and Heliophysics community. That's a great learning resource. It's a great community resource for our community. And the Python gallery, there's an extensive gallery just in HelioPython of the many different things that you can that users commonly want to know how to do. There are simple examples and there's some complicated examples. As I said before, the Goddard, the Advanced Software Technology courses, they have a large number of courses that are available. They also have a competency test that you can determine where you might want to start. I learned through Michael Kirk was my tutor. So I put Michael Kirk's courses. These are SunPy. They're not magnetospheric, but a lot of this is really applicable in general and also if you are interested in looking at also adding solar data to some of your items, you can do that. And then the Helio ML book, the Machine Learning and Heliophysics book. Has examples throughout all of heliophysics that are published results that are, and these are all machine learning things done with notebooks. And so you can access a lot of these publications, the source code, and excellent explanations there. Finally, announcements. If you are interested in the Helio machine learning environment, you can come to the Machine Learning Helio conference. The early bird registration deadline is today, and the poster abstract deadline is tomorrow. So this is well timed. That is ml-helio@github.io. The Python and Heliophysics group is doing a summer school. If you go to their page, you can see the event is free and open to anyone dedicated to learning Python. And I can guarantee you these courses will be spectacular. If you're lucky enough to go to Madrid, Spain to do the course in person, you can do that. Otherwise, there will be virtual participation options. If you're advanced, there are some publications working on sharing and information on the development and the state of the art of Python. So the Frontiers in Astronomy and Space Sciences and Frontiers in Physics are jointly soliciting manuscripts on that. And finally, please attend the next seminar. It's the early career seminars for the last one. The first seminar was was just fascinating, and so the next seminar coming along is going to be next Monday. So yep, we're coming up in the end of the hour. Kyle, do you have anything that you'd like to add?
I would like to add my thanks to you and your group. I know this takes a lot of work, and so I really appreciate that you guys have agreed to give these, especially the first set. I think they're going to be really helpful for the community. I do want to emphasize again just a little bit, practicing is going to make perfect. There's lots of ways to practice. The Google Colab is really nice because you don't need to install anything. But if you do want to move to Python, Anaconda is probably going to be one of your go-to resources. So I would suggest installing that before next month. March 21st will be the next one. And I believe it's going to be looking at data types and NumPy, right, Barbara?
Yeah.
Yeah. And then the other thing I want to emphasize is if you have stuff that you want to look at or what you're interested in, let us know. We can try and find speakers to address those topics. Or if you want to volunteer to give a seminar, that would also be really helpful. If you're an early career, we do have the early career seminars, but if you'd rather as a postdoc or early career researcher that might want to get some experience teaching or tutorials, we'd be happy to have you give a tutorial within Python. So again, stay in contact. Let us know what you guys want to see. So if there's nothing else, there was a few questions in there, but I think they're all getting answered. We'll hope to see you guys next week, and we hope to see everyone at the next tutorial as well.
Yep. Great. Thank you, everyone.
Thank you, Barbara. Thank you.
Thanks, Barbara.